Alright, so this problem on the Webassign asks you to find the magnitude of the gravitational force exerted on the moon by the sun and the earth, as well as the direction of that force. So to do that, first we're going to use Newton's law of universal gravitation. So that is force of gravity equals the gravitational constant, G, big G, times mass 1, mass 2 over r squared. So you'll do this for the Earth-Moon interaction. You'll also do this for the Moon-Sun interaction. Once you do that, you should get a couple of forces, and one of those forces will act on the moon toward the sun, and the other force will act on the moon toward the earth. And once you have both of those forces, I'll call them Fs and Fe. You can call them whatever you want to. You're going to perform a vector addition on them. And in vector addition, you add the vectors head to tail. So the head of this one to the tail of that one. And you're going to solve for the resultant. And the resultant vector would be visualized as this. And by the way, I don't recall the scale on these right off, but I think the one on the sun it may actually not be larger. But anyways, that's without performing the calculation right off. Let's see. I'm looking at the correct answer here on Webassign, and I think that it asks degrees below. Oh yeah. So that is that. Yeah, the sun force is actually larger. Hold on. Yeah, that's right. The force of the sun on the moon is actually greater than the force of the earth on the moon. You might be like, oh my goodness, why does the moon stay in orbit? Well, keep in mind that the Earth-Moon system is in orbit around the sun. So both the Earth and the moon are still gravitationally attracted to the sun, but maybe we don't notice that gravitational attraction as much because we're actually in orbit around the sun. So both the moon and the earth are in orbit around the sun. So you have to keep that in mind if you're trying to think deeply about this. But anyways, once you find those gravitational forces, you can find the resultant with Pythagorean theorem. R squared equals the sun force on the moon squared plus the earth force on the moon squared. And I think y'all can probably solve that. And then to get this angle below the moon-sun line, okay, once you know the resultant, you could really pick your trig function if whatever you wanted. I'm going to use the two values, so I'll do tangent opposite over adjacent. So and theta then is going to equal the inverse tangent, or arctangent. Let's not forget this. All right, so that's how you do it. Hope that helps.